Okay, this is for Algebra 1-1, Section 2.5. We're going to work on the distributive property. So in your notes, the very first problem that you'll see is 4 and then parentheses, y plus 3. You get a good pencil. You multiply that 4 times each of the items inside. It's distributing to each, so it's 4y plus 12. If you have a problem like this, it would be -1 that is being distributed to each. So it's -1 times 4, -1 times -y. So it's -4, and then a negative times a negative would be a positive y. Should circle your final answers. On this one, the only thing that bothers most students is having the number that you're distributing behind it. If that bothers you, just write it to the front, -3 times m minus 5. Using the commutative property, you can change the order of your items here. So you can keep the parentheses around it if you want. -3 times m is -3m. -3 times -5 is positive 15. Remember, they're both negatives, then it's a positive. Okay, next one. We have a half this time. I'm not going to rewrite it. You can always do it on this side. So a half times 2n. Half of 2 would be 1n. Half of 6 would be 3. So 1n plus 3. We also have distribution in division. A lot of times we don't practice that one as much, but we should. You take the first term, 4n over 2, plus 6 over 2. Now reduce. 2 goes into 4 2 times, and there's only a 1 left underneath, which we don't have to write. And 2 goes into 6 3 times. In this one, we have 12 over -8 minus 24b over -8. 4 would go into both 12 and 8, so we reduce that to 3 over 2, leave the negative out front. 2 negatives make a positive, so that becomes plus. And then we have 8 goes into 24 3 times, and there's still a b. Okay. Next problem, identify the terms, like terms, coefficients, constants in each expression. Okay, so we need to go through a little bit here. You'll have lots of these to practice on tomorrow in class. First thing is, terms are anything that are between the plus and minus. So if I just write this down here, terms are between plus and minus signs. Those are the terms. Now, if terms have the exact same, like terms have the exact variable or variables with their exponents. Okay. And a constant term does not have a variable in the term. Okay, so looking at this first one, we identify the terms. I do it by thinking about when I was a kid, I used to scream out the window of the car when we were traveling because I like to hear the difference the sound made when big trucks came by. So I look at this and think of sound waves. It would hit this and have a different sound. It would be like, ah, and then it would hit that and go, ah, real loud. And then, ah, real quiet, and then real loud. So I just look at the sound wave kind of thing. There's 3 terms there. The terms here, there's one, there's another, and there's another. The terms here be this one, and this one. It looks to me like I did not give a like term. That must be a typo. Let's change this to being 6x squared. Let's change this to being 2t squared. Just so we can practice with like terms. Okay, I didn't identify either coefficients. Are the coefficients the number attached to a variable? Okay, so right here, 3 and 6 would be coefficients. And 14 would be a constant. Now, because we changed those, the like terms would be 3x squared and negative, the negative comes with it, negative 6x squared. Okay. Coefficients for this one would be what's in front of the x squared, which is 1. And the coefficient for this would be 2. The constant here is the one without the variable. That would be 4. And the like terms here would be 2t and 1t squared. So 1t squared and 2t squared. Those are like terms. Here we don't have any like terms. We don't have any variables that are the same. The coefficients would be negative 1 in front of the y and positive 1 in front of the x. The constant is 2, and the like terms, like I said, we don't have any. Now, one thing with like terms you should be aware of, because of the commutative property, xy and yx are like terms because the order can be changed. 2 things that are not like terms would be xy squared and x squared y, because the exponents are not identical even though the letters are. So that would not be like terms, that is like terms. Okay. Here it's asking us to simplify the expression. We take our like terms and combine them. 5 plus negative 11 will be combined. It's still being multiplied by x, and then minus 4 is not a like term. So 5 minus 11 is negative 6x minus 4. Here we need to distribute this negative 1 before we can do anything else. So that makes it a negative p cubed. That would be a negative 3p squared. And this would be a positive 2, plus 4p cubed minus 5. Now we look at our terms and see if we have any like terms. Hopefully you've noticed that we have a 4p cubed and a negative 1p cubed. 4 minus 1 is 3. So we have 3p cubed minus 3p squared. And now we have like terms of positive 2 and negative 5. 2 minus 5 is negative 3. Next problem. We need to distribute that 3 before we can do anything else. So we have 12x squared minus 6x plus 3x minus 5x squared plus 2. What I'd like to see oftentimes in this kind of problem is use the commutative property, rewrite it with your like terms close together. So we have 12x squared minus 5x squared minus 6x plus 3x plus 2. These are like terms. 12 minus 5 is 7x squared. These are like terms. Negative 6x and positive 3 is a negative 3x plus 2. In the next problem, we need to distribute this negative 1 to each of these terms. Negative 1 times m is negative m. Negative 1 times 2 is negative 2. At the same time, let's go ahead and distribute this one. 3m. 3 times negative 4 is negative 12. Now we rewrite with our like terms together. Negative m plus 3m minus 2 minus 12. 3m minus m would be 2m. Minus 12, minus 2 minus 12. Those signs are the same, so we add them together, give it the same sign. 2m minus 14. That concludes 2.5.